Okay, so let's look at this particular example. You see, they are saying that we should determine the behavior of the series, but they didn't say whether we should use comparison or power series. Okay, and so because of that, we assign 2n over n squared like this. If we take the values of this particular thing, the sign values, some are negatives, others are positives, and they are not equal. Okay, so not the series is not alternating. It's not alternating, and uh, it's not alternating, and they don't cancel out. Okay, so with this type of question, some are negatives, and they are not equal. They are not equal to. So what do we then do? So right now, we need to find a way of solving this particular question. Okay, and so if you look at the question, we know that for the sine function, let's say this, we know that the sine function, this is sine of x is between less or equals to -1 and then +1 like this. Okay, and so if we have the sine function to be behaving like the values are between -1 and +1, and that will mean that the series n equals to 1 up to infinity of sine 2n over n squared. So this one actually, so this will imply that if we take, so definitely we have -1 also less or equal to sine 2n less or equals to 1 like this. Okay, so this will be less or equals to the series as n equals to 1 of infinity of, so if I'm putting 1, then this will be less or equals to this like this. Okay, so we can now have this particular, we can now check whether this series is convergent or divergent. Okay, this one like this, we can either check using maybe the Gauss test or something. Okay, and since that will be sandwiched, if we check and this one is convergent, in fact this one too is less or equal to the sum n equals to 1 to infinity -1 over 1 squared like this. Okay, so if we check and this is convergent and this is also convergent, then it will mean that by the sandwich theorem or squeeze theorem, this one will be convergent. Okay, so let's check and see. Okay, so right now we have maybe I'll just use the Gauss test. So by Gauss, if I take an plus 1 over 8, if this one can be written like that, then that will mean that we have 1 over n plus 1 all squared divided by 1 over n squared. And so this will imply that we have 1 over n squared plus 2n plus 1 times n squared over 1, which is equals to n squared plus 0n plus 0 all over n squared plus 2n plus 1. But by Gauss, we know that if we take beta minus alpha, and this is greater than 1, then we are saying that this converges. Okay, but if beta minus alpha is less or equals to 1, then this diverges. What is our beta? Our beta is this, our alpha is this. And so this will imply that if that will be 2 minus 0, this equals to, this is equals to, okay, this equals to 2, which is greater than 1. This implies that the series that converges, converges by the Gauss test. Okay, so right now we've checked and we know that the series this n equals to 1 up to this of 1 over n squared converges. It converges. What about this one equals to 1 up to infinity of negative 1 over n squared? This one too will converge. Okay, this one will converge if we take the absolute. Okay, and so we will see that by absolute convergent test, this one n equals to 1 up to infinity of this also converges. That one we didn't do anything, just that when we take the absolute values, because we'll be getting negative, so if we take the absolutes will just be the same as having this one. Okay, so because of that, we can then see that therefore sine 2n over n squared is between 1 and then positive 1, and this will imply that since this 1 equals to 1 up to infinity 1 over n squared and equals to 1 to infinity of negative 1 over n squared converges, then this one too, n equals to 1 up to infinity of sine 2n over n squared converges. That's all. Thank you for watching.